days, viewers at home and dear students. I am Olashupo Kolawole, your basic electricity instructor. And today on the topic, we are going to be looking at electrical quantities. The aim of this lesson is to explain some of these quantities in relation to live application and get you familiar with the expectation of the examiners during the final examination. So at the end of this lesson, you should be able to explain the quantities. You should be able to state the symbols and the SI unit of measurement, and likewise get familiar with the importance of these quantities in relation to the home appliances. To start first, these quantities have so much to do with how electrical and electronic appliances works. You might have been wondering how your TV set, radio set, and other electronic gadgets behave the way they do. It is nothing so serious. It is the effect of these quantities that bring about the functionalities of these appliances. So, these quantities are phenomena that are responsible for the operation of our various electronic and electrical appliances at home, even in schools, offices, and industries. They are simply processes that must take place before these appliances will be set into operation. I'll quickly look at 5 of these quantities. The first is the voltage. The second is the frequency. The third one is electrical current. The fourth one is resistance, reactance, and impedance. And finally, we'll look at the power. Now, the voltage, as the first one, actually deals with the force that is responsible for the operation of every appliances at home. Now, I would like to first look at this tap water system. The tap water system gives you an insight about how this works. The valve represents the key. The mouth of that pipe is the resistance, while the water that drops into the bucket is the current. The amount of this current you use per time is what you refer to as the power. Voltage symbol is V and is defined as the cause for electricity production. So it's the electrical force or push, the pressure that causes electrical charges to move in an electrical conductor. It is the energy per charge that is measured in joules per coulombs. It can be EMF, that is the voltage for no load, or PD, which is the voltage for a loaded circuit. You can see the difference between them in that table. The voltage when the circuit is delivering current is the PD, while when it is not delivering is EMF. It is load voltage for PD and no-load voltage for EMF. It is a closed circuit voltage for PD and an open circuit voltage for EMF. Now, if you look at the picture of the refrigerator freezer shown, the 127V, which is being pointed to by the arrow, shows a particular value for this particular freezer. The V there is volt, and volt is the SI unit for measuring voltage. So 127 means this is the amount of force needed for this freezer to operate. Now, let's move to the second one, the frequency. The symbol is F and is the number of cycle or oscillation per seconds. The more cycles that occurs per seconds, the higher will be the frequency. So it means as the frequency increases, the voltage likewise increases. And this depends on the rotation of the motor generator that is used in generating electricity. It can actually be 50 Hertz in the case of Nigeria and 60 Hertz in some other country like United States of America. From the appliance shown here, this is a Dell appliance. You can see the arrow is pointing to 50 to 60 Hz. The Hz there is representing Hertz, Hertz. This is the SI unit for measuring frequency, and is either between the 50 or 60 like I have told you. Now we move to the third one, which is electrical current. If the voltage is the cause, then what is current? Current is the effect or the result of the voltage processes. It's the actual quantity that makes the operation of our appliances visible. If any appliance is seen working, it's because electric current is flowing in the circuit. So, current will flow if there are free electrons and a conducting material. In this regard, we can say current is defined as a rate of flow of electrons or charges. It's 1 coulombs per second. That is, it can be defined as a quantity of charge that is flowing in the circuit per second. Now, if you look at this particular picture, you will see the same refrigerator freezer and the arrow is pointing to 2.4 A. This A represents ampere. Yes, so when you look at any appliances at home, when you check the body at the back or beside and you see something like 2.4 A, it's actually pointing to the current rating. And here, 2.4 is actually the value, which is the magnitude. Now, if you look at this other one, you will discover that we are talking about AC or DC. From the symbol which arrow is pointing to, you could actually have the 10.1A, which is the AC current, or 57.3A, which is the DC current. DC is unidirectional flow. It can be stored. An example of DC appliances at home, your TV set, your radio set, and some other ones. As you can see, they are devices that are not directly connected to the circuit, but the voltage supplied is first rectified before they are fed into the appliance operating circuit. AC, on the other way, is a periodical back and forth flow of electricity, but this one cannot be stored. Your ceiling fan, your refrigerator, and electric pressing iron are few of the examples of AC appliances at home. So, what we are trying to say is until you plug your appliances, the voltage supplied by the distribution companies or the one you loaded on your prepaid card is yet to be utilized because current is yet to flow. And I'm going to be looking at resistance as the last one for this particular episode. Now, the resistance symbol is R. It's a quantity that controls the flow of electric current in an electrical circuit. Now, resistance is how wide or narrow the channel of electric current flow is. So when you talk about resistance, as the resistance increases, then the current will reduce. So it means the higher the resistance, the lower the current. And the lower the resistance, the higher will be the current flow. Resistance is defined as the electrical quantity that opposes or limits the flow of electrical charge. It is the degree to which the device impedes the flow of electric current caused to flow by the voltage. So, it is actually the quantity, yes, the quantity that measures how your devices reduce the electric current that flows through it. This resistance does a lot of work. It helps to control the inflow of current. It will be used to adjust the signal level to divide voltages, bias, and actually for active elements. It is represented by R, and the SI unit for measurement is ohms. It is actually caused by resistive component. So it means this particular resistance is a value that you have to take note of, because with the presence of this particular the electrical quantity, it controls the flow of current in our appliances. So if you look at your volume, the volume set for your radio, the one you can turn, and you can actually increase the volume or reduce it. That particular device used to control the volume is this resistance that we're talking about. So you can see it can actually controlling the flow of that particular current to adjust the signal level. So on this note, I will be rounding off on this particular first episode. We have looked at the definition of electrical quantities, and we have seen three major aspects of it, which is the voltage, the frequency, we have seen the electric current, and finally, we have actually looked at resistance. Join me next week as we look at the concluding part of this particular teaching. This program is brought to you with the support of Festo.